Carlos! Hey, dude. How's it going? Oh, my social streams. What happened? We should be back. Carlos, did you ever finish the Python crash course? What's going on with this thing? Why can't I see chat? Something's going up. What the heck is going on? My chat is not working. Hold on, guys. Trying to figure this out. Oh, whoops. Oh, come on, I keep being an idiot. There we go. Okay, leave that open. And then let's open it. Alright, let's get chat here. What's going on? How does this work? So annoying. What's going on? Yo. No. Ugh. Why? Why now? Nothing's changed. Ugh. I'm trying to figure out this chat, you guys. Sorry. What is that? Twitch. Anime girls on Twitch. What is this? Oh my gosh. Twitch homepage is like cringe. Okay, let's see here. Oh, I think we're loaded up. I see 7. I got a 7 now. Let's get a message. Come on, here we go. Yes. All right, we got chat going here. Let's go. We're back. All right, we're good, boys. What's going on, everybody? Welcome back into the stream. Hope you're having a wonderful day so far. My name's Michael. Welcome, welcome. Today's August 25th. It's a little before 7 p.m. today. Should have a good stream, so thank you truly for being here and hanging out. Let's get this show on the road. Yes, Twitch is going. Good. Just ain't nobody here. Okay. Sweet. Shout out Luna Lounge for the tunes. All right. Today. What to do? What to do? How's everybody doing? If you guys are here, give me a chat. Hello. Who's here? Who's here? Who's here? Show yourself. What should we work on today? Should we read? Should we? I think what we should do is... What we should do is probably MIT. Because we are behind. Long time no see, Mike. Tim! Yo, I did an early morning stream, yo. Y'all acting like I didn't stream at all this weekend. Come on, don't do me like that. I did an early morning stream yesterday where we read a chapter out of Introduction to Algorithms. We read all of chapter 1, which is a great read. I'm planning on doing, trying to do full chapter reads and really just keep the book going. So yeah, I appreciate you guys, bearing with me for the Saturday. My lady was here, and we only get to hang out on the weekends, so I make the most of our time together. I can be a degen coder throughout the week, but I gotta be a good boy on the weekends. Right. All right. All right. Hello, everybody. Welcome into the stream. Yeah, we're behind. We need to keep going with our MIT here, honestly. So we can watch this lecture, but we have to tackle problem set 3 before we can move on to the next lecture. So I'm thinking, do we take a stab at problem set 3 for a little bit and then watch the lecture?
Translation. MRS Deming kicked Mike off the
Yeah, just I feel bad, I don't like to, I feel like a bad host, and she's here only for a couple of days, or I gotta make the most of that time. What's important. There's always, you're gonna be able to code. All right, welcome everybody, welcome. Let me get my light. My light is not in here. Hold on. She did take my light. Hold on. Chill. Relax, everybody. Relax. Okay. Okay, let me show you guys what I did over the weekend for the code, though. Hey, thanks for 2,900, by the way, on the sub count. Boom! Big booms for that. I appreciate you guys on the subs for the, thank you guys so much. 2,900. We're 100 away from the CS stream. We're going to do a Counter-Strike stream. We're going to play some Premiere. I'm rank 15,000 about. Going to grind for 16,000 during the stream, hopefully. And open up some cases and give away some skins. So,
How's it going, Michael?
hey, Warren Buffet. How's it going? I like that name. Is it Warren Buffett? Like Warren Buffett, but Warren Buffett? Warren Buffett? Let me show you guys really quickly before we dive into the MIT. What I was able to write over the weekend, just kind of, at night and whatnot. So, I reorganized our structure here.
Stream right.
3,000 minutes, yes, stream. Bro, how many days is that? Okay.
LeMayo.
So, we have,
Better at this?
Did he get any better? He's asking you guys. You guys have to ask him. All right, yes, you guys have to give an honest take. Okay, so I did reorganize our file structure for our Birdie Rose Close project here. So what I did is we have client, right, which is where we're going to house our React and Tailwind front end. Cool. Invite was right, is where we're going to host. And server is where we have our backend stuff. So we have our app, which is our, server application stuff. We have our virtual environment and our requirements. In our app, we have our data, we have modules, and we have scripts. In here, we have data here. This is where we just house, data, like our product pictures, just some, database JSON. These three files, data.txt, used item numbers, this one not, sorry, test JSON and data.txt. Those ones are kind of just dummy files for now. I just am using them as reference for my scraping and stuff, but product pictures and database JSON and used item numbers will stay. Unless we do something different than JSON here. We'll figure it out. But I went ahead and wrote this here. So I was able to get the pictures to sort themselves into their own files and directories. So I'll show you guys what happens here. If I delete this, and then let me go ahead and that's fine. We can leave database JSON. That's okay. In my models here, this is just where I'm housing my objects, right? Product. If I want to make more objects, I'll put them in there. But that's just where I'm putting that. And then scripts is where we have our scripts, such as our generate item number script. My Discord poll finally closed. Okay, let's go check it out. I posted a Discord poll for our front end, which I think is going to be React is going to be the winner here. I think React is going to be the winner. Yeah, 100% React, right. Alright. You guys have spoken. So our Depop scrape, right? So what I wrote here, let me back it up, is in our download picture, I just used the OS directory, and I just altered our save path to include a directory path to the Birdie Rose Close ID, right, given within the parameter of the function. And then the OS make durs function just makes a dir on that save path, and then we open that save path and write to it. So it's not too hard right now. Now, there is no asynchronous functionality with this right now. It does have some halting going on, which isn't too bad, as we're not downloading these pictures in crazy resolutions or anything. But if your internet connection maybe lags, I don't know. My internet's pretty fast, but if I haven't tried it with slower internet or if it would really matter. or with even slower computer, really. But yeah, it's interesting. I mean, I'm streaming and I'm doing this, so and it seems to do it just fine. So let's watch what happens in this product pictures directory here as I run our Depop scraper. Oh, this might not work actually. So I I reorganized all the files, and so our links to stuff might be broken here. Oh no. Oh no. So this is going to be load from use item numbers txt. This is not the right path. This is going to be server slash app slash data slash use item numbers txt. I don't think it's gonna work. Yeah, and this guy too. We're gonna have to do app.models. No module app. So we have to do server app. Module server now. Ugh. I'm so bad at these file pathings, dude. I really don't know. This really doesn't work. No module name server, app server products. If I just do dot here, no. Gosh. It's gonna be no module app, right? If I did dot models, if I did models dot product, no, actually no models. No, I can't even do that. No module product. So, this is so annoying. So how do you go back one and in? Models from slash models dot models. No. See, this doesn't work. Anyone know why? So how can we go out of scripts into models into product? I'm so trash at. Is it this? Okay, so what if we did app here dot models? No, that doesn't even work. Import error. Attempted relative import with no known parent package. Models doesn't work. So if we go into models and create a init.py file, right? Module in model still. So if I did here, no. Ugh. This is so frustrating. I know. Okay, so we say how to import product from models where from just models import. Now if we say, so models has to have an init and so does scripts. So we say no module named models still. Oh, I'm being dumb, I think. So still, even if we're CD'd into server, oh, so still. There's still no module found. This is annoying. Is it class product? Yeah. Models.product. Models has an init file. From the roots, let's see.
Question: do you ever use ChatGPT for help?
Yeah, I ask questions for sure.
I'm just wondering if that helps you learn.
Yeah, definitely. I have to ask questions and figure stuff out, but I'm asking it right now, honestly, because I'm trying to figure out this directory stuff, but from the root. So if we go oh my gosh. No idea.
I am also learning programming. I am learning Django right now. Do you have any tips? I started with HTML and CSS and a little bit of JS. Now I am learning Python. Did you take any courses or just YT videos?
I completed Harvard CS50P, CS50X. I'm taking MIT 60002. I just wanted to fix this little this thing so we can run. I can show you guys this updated code that I wrote and for the downloading the images, and then we're gonna get into watching the next lecture for MIT. So definitely stick around here for about 15 more minutes. I'm gonna try to fix this here really quickly. I gotta debug, but once we get it fixed, we're gonna watch the next lecture. So stay here. He's back in. So if I say app.models.product, no module app. Ugh.
How did data structures and algorithms go?
We're still learning them for sure.
Sounds
Definitely an
good.
ongoing
Info to
process.
subscribe. I'll learn with you.
Nice, that sounds like a great idea. Why? This is so frustrating. Why can't we import
Mike, are
product?
you applying for jobs or PhD RN?
I guess if we say if name equals to main, right, we're going
If
to
you're learning Python, he has a lot of Python videos where he went over
product.
different books.
We don't want to run product. That's so dumb. No, how can we import this? Ugh. After product. So I don't know why this ain't working.
Thanks, Worm Buffet. I will check them out.
Okay, let's run from CD server.
Also, do you stream every day?
I tried to. I tried to. I didn't. I streamed yesterday. I have some days recently this summer that I've been kind of. Python treat the app. Let's run this. What just ran? What just created? Module found server over here. Module name server in line 3. Where? Product pie. Product name app and line 3 of Depop scrape. What are you talking about? Here we go. Ah, here we go. Okay, here we go, boys. We got it. Okay, so we gotta figure out this pathing here. For load use item numbers. Let's go like this. Does that work? If I hit this, no module found app, but if I hit this server or Python -m, what does this mean? What does the -m mean?
Are there any boxers available on Depop?
Yeah, we're custom on my OF. Chill. No. Chill. Alright, we got it. Okay, here we go. We got it. Okay, here we go. Here we go. Okay, we fixed it. So if I CD out of here and run just from here, we get that. But if I run server.app.scripts depop scrape, no module app. Okay, so then if I go cd server, run python m app.scripts. Huh. Man, I gotta learn more about this file import crap. It's bewildering me. Okay, so if we run though, it did not download. Ah! Okay, hold on. Where did it download onto? Okay, download path is server/product pictures. Oh, there they all are. Okay, hold on. Gotta delete that. Okay, so it's path is going to be data/server product pictures, right? No, wrong way. So that goes, where's the saving out of? In server. Okay, so we got to go. What? File path is data server product pictures. Not data server product pictures, it's slash data here. Oh. Come on. Okay, so, how about my tunes? Hold on, we're gonna get into the MIT in a second. Hold on, patience. Thank you guys. Leave a like. We'll get into it soon. Leave a like. Grab your snacks. Make your popcorn. So this is saving in server still. Okay, so it's saving in server. So delete. So we'll say this folder this folder slash dot data, right? I think that'll work. No. Oh wait, into server still. And so we'll go slash data product. I think that's the combination we're looking for. Oh my gosh. No. Dang it. Crap. We'll get relative path. Let's paste here, I guess, and let's try it. Happened. Frozen OS.
Does birdie mean what I think it means?
This is running. Download picture. And this is running inside a script, so we need to go.
File path needs to be relative. Golf reference.
We say app.
How long have you been learning to program?
I've been teaching myself a little over a year now. About every single day. There we go. There we go! Okay, we fixing stuff. Now we still need to fix a couple other links here. So this needs to be
Tim Law.
app slash data slash database JSON. This needs to be app slash data slash database JSON.
Let's go.
Let's go! You guys got my back. I like you guys. Leave a like if you're here. Leave a like if you're here. I was here. Okay, so. Okay, watch what happens. Okay, I'm going to delete these again. Okay, so think of it like this. This is the whole idea of the system. Okay, in our database JSON, think of this as, okay, clear your minds. Home. Okay, so we got 22 people in here. Hello. So I'll give a quick intro. My name is Michael, 26 years old. I got a degree in human biology and a minor in chemistry, and I work as a professional formulation chemist for a biotech company. I have been doing that for almost about 4 years now. I'm a scientist 2, moving up to scientist 3 pretty quickly here soon, I think. And I specialize in kind of building kind of advanced products for my team, manipulating kind of matrices to predict theoretical yields, kind of using my programming skills to advance products, improve things, and yeah, it's pretty good. No, get out of here! No, the pod ruined my thing. Anyways, I've been teaching myself how to program every single day for a year. Now this summer I have been taking a few days here and there off, so don't blame me, but I've been getting outside and touching some grass, so I have good excuses. Anyways, so let's just this is a project. So me and my girlfriend, we run a small business where we sell and or rehome rather vintage clothes
Nice
online.
data
Now,
structure.
um, nice. Right. So rather than so a lot of our competitors, probably heard of like resellers online that resell clothing, and you might have kind of a negative taste in your mouth regarding that word because in my opinion, I do too. Like those people, they honestly just rip people off. They find things for very cheap and they mark them up insane on their margins, upwards of thousands and thousands of percents on their margins. Which, yeah, I mean, like you can do that if you have buyers that are willing to pay that price. But personally, um, as a smart shopper, but even though I like vintage clothing and I like fashion, and sometimes I wear the same 5 shirts every single day, as you guys probably know, um, I, uh, I, uh, I don't like spending a lot of money. So our business model primarily revolves around really finding nice pieces, vintage pieces that for primarily females right now, but we're starting to expand into unisex and male clothing as well. And just finding them at a good price for our customers and offering them at that rate, right? So that's the whole thing is just getting items, but selling them at a good price so it's fair, everyone's happy, and then we serve our customers and we make money. So the whole goal of the company really isn't to make a ton of money at the moment. It's mainly was just to supplement my girlfriend's hobby of thrifting, and it successfully has done that just by breaking even basically. But now I'm kind of interested in seeing if I could ramp this up and kind of merge with my programming skills and kind of take on over like a larger project here, and kind of create like a it's kind of cringe, but kind of create like a little tech company here. Now think of it like this, like we do sell physical product, but there's no reason why we can't use my programming skills and some scripting skills and things like that to automate these processes and really make it like a streamlined process. And then I really have some goals of actually taking over the inventory. My girlfriend's kind of tied up doing her own thing. She's a professional dancer, and she went to school. She has a degree in dance, and so she does do that. And so I am probably going to take over this a little bit more in terms of managing the inventory. Actually, she will be doing a lot of like the posting, obviously, because I need her for the modeling and such. But I think I'm going to try to take this over and see if we can kind of grow this on the channel. And if you guys are willing to participate, you can reach out to me as well on my Discord. There's a couple of you that were interested in kind of working on the website with me. So my whole idea here is I have structured, let's just kind of go over it, right? So let's say that you buy an item, right? You go to Goodwill or you go to a thrift store and we source an item. We find out something we really like for our customers at a price we like that we can, market to our customers. So let's say that happens and it's this item here, right? So we would have some sort of, I think, a tokenized URL. I don't really want to have login or sign in on our website. I don't really want to manage people's data like that. You'll see why we kind of have a unique model here, in the sense that, and I'll get to that in a second. And we're using Depop. So what I'm trying to do here is, let's say that you acquire an item for the first time. So we'll have like a tokenized URL that we can visit, that she can visit or I can visit to actually load in the item into the system. And when you load an item into the system, all you'll have to give it is, you'll give it a title, you'll give it the status will come automatic as like available, right? The sub price is, this is null, right? Let me just copy some stuff. So just kind of mimic as if we're inputting some data here into like a forum or whatnot. And yeah, so it's pretty cool that way. So, right, the Birdie Rose close ID would stay. That just is pulled from the key that was generated. Like we have a function here, generate item number, which generates a unique item number, referencing our used item numbers. We're using some random functions to do that for us, which is pretty cool. I whipped that up in like an hour or so. I think I did that off stream actually. No, I haven't done it on stream. Can't remember. But yeah, so imagine, there's no sub price, so you would have like a seller, no sub fee, no buyer fee, cost of good, right? So we would say, okay, this cost us actually like $10, right? Or like $5, right? It's kind of more like $5 to $10, right? Size, we would input this. Let's say this is like a size small, right? Condition, we would input this as like good, right? Great, new, like new. Brand, let's say that this brand is like, we'll just say brand. We can provide a description. So, but this is pulling from the Depop description currently. We do have a Depop description indicator, but haven't really done that. I don't know how I'm going to handle the descriptions yet. All I know is that the only thing that is required to link this system together from Depop to our system, and you'll see why I get there in a second when we run it, is having our ID, our internal ID listed in the description of the item, so I can parse it out to understand that, okay, that item is now on Depop, and so we can now sync it back and forth, okay, right? Because the system doesn't know, rather than us going into the system and saying, okay, we posted this item on Depop now here's all the information. The goal is that we can just input items and then post them on Depop. Automatically the script will run, right? The script will run and then like link up all of the items from the database that were then posted, and then I'll fill in all the information from Depop therefore, which is pretty cool. So, and then it can just do that automatically, and then we keep refreshing for sold things, and as things update and whatnot, we can keep running the script. So, clothing type, let's say that this is, we're gonna say just like shirt. So Depop ID, this would be null here because it doesn't know it's on Depop yet. The slug from Depop would be null. It doesn't know it's on Depop yet. Sold would be false. Source, we'll say the source is, we'll say Goodwill. Acquisition date, we'll say was 2025. We need to do a string, 2025 dash, we'll do today, 08-25. Right? And then the list date will also put as that as well. No sold date, no sold platform, no pictures, and no Depop description. So just take this first item here, this first, JSON entry as our tester. Don't worry about the ones below it. Say we just acquired this item, and now we're entering into the system via a private token URL that'll be on our page. They'll be accessed from like an internal, like an admin or whatnot. So, because I don't really want to do users and stuff. Yeah. Okay, so now watch what happens. All right, so I'm going to drag this over, and let's go over to here. And so, also product pictures here is empty, as you can see. There's this directory product pictures. It's empty. And what's going to happen is let's go run our script. All right, it's going to start going. It's going to scroll. I'll pull this over so you can see. I'll keep the Chrome out. So it's scrolling the page, printing the increments as it goes through the page, the heights of the page, showing how many new items it found through each parse. I'm only having it parse out the first 6 items for our testing right now. And let's go ahead and get back in here. All right. So we do have some problems. So this did overwrite information. This did overwrite our information, which it wasn't doing that before. Because I only have it selectively overwriting some things here, such as sub price, total price. Yeah, I wonder what's happening here. We are getting the pictures though, right? And they're associated to each of their individual items, which is cool with their naming. But our objects, why would it be doing that? So it scrolls to the bottom for Depop ID and product in Depop listings items. right? These are all the Depop listings that were parsed out. Right, if loaded products, we're gonna match product from DB equals to loaded products dot get vertical equals ID in that. That's sold date. So why is title updating here? I'm curious to why is this overriding? I don't have it set to override. Yeah, it overrides it back to null. Shape products. Okay, so then what products are we passing in? We're saving products on Depop listings.values. Oh, I see. Okay, so what's happening is we're opening up the matched products from the database here, and we're equalizing that. And then at the end here, we need to set matched product from DB. Right, we're not updating the Depop list. We're going back. Well, yeah. Right, we're just taking the current Depop listings. So we update the current product, and then we set the product equal to the matched product from DB, and then that should do it. So if we go here, let me go back to our previous example we had, where we had info in here, brand. There we go. Now if we run this should work, because now we're setting the product that we updated from to the totally updated product from the database now with new values, and then saving that and moving forward. So if we run this now, downloads the images, there it goes, come on, come on. Well, I already have title null here anyway, so that should, I probably should have, hold on, let's get out of here. Let's make this title. All right, come on. Show me the money. Show me the money. All right, all this should stay, right? And just get the updated values from Depop. Fill in the blanks, right? Fill in the blanks, basically. Oh, what? No way. So the product. What? So we update the value. We update the value of the product to the matched product from the database, which this product is in Depop listings, because that's what we're looping through. Huh, I wanna see. So I am looping through the found products from Depop that contain the parsed info from Depop, and then filling in the blanks in a way for the equal products linked to the database, then saving the product as the total new updated product to then be saved in save products. But it is just saving the original Depop listings. Just a local variable. Ow, come on. I knew that. Okay, so we just have to go. Oh, that was such an easy fix. I can't believe I didn't figure that out. We just have to go Depop listings, right? Key of Depop ID, right? Back on that same loop item that we're on, and then override it there at the very end, and then move forward. Yeah. Oh, okay. Here we go. Let's try this again. Okay, here we go. Here we go, gents. Ladies and gents. Come on! Show me the money! Leave a like on the stream if you're here. I think we fixed this. All right, it should just fill in the blanks. Fill in the blanks if they are anything to be filled in, right? So if it's sold, it's not going to change. If it's not sold, I mean, right? From fall. Yes! Let's go! Ain't that something? Let's rock. All right, so it filled in the sub price, right? There's no seller fee or buyer fee filled in yet because it's not sold on Depop. It kept our cost of good. It kept our size and condition and brand. It didn't get any description because I don't think I'm actually getting the description out right now. Or maybe I am. Am I setting description null here?
Hi there.
So I say description. Yeah, I'm not parsing out the description. Oh, I am parsing out the description. So why did I get null there? Oh, I'm not putting it here. Right, so now if we run it, this should get filled in here. Let's watch it. All right, we're gonna watch MIT here right now. We're gonna watch MIT right here after this, once this fixes. This should fill in the description. Look. All right, cool. All right, so the whole purpose of this, let me get caught up on some chats. Sally Queen, how long you been learning to program? Hey, I've been teaching myself on the stream live. I've captured pretty much every single moment of my programming journey, so follow along if you wanted to see that and do that too. I've been doing it for about a little over a year. Hey Tabor, how's it going? So the program is basically identifying what items have been posted from our database, and linking that relevant data, that Depop information, to our database, so we don't have to fill it in. Honestly, I prefer coding on Mac for sure. I've never really actually programmed on Windows, but Windows has kind of just been losing my love lately.
Subathon boys, let's get Mike to 3K.
Yeah, we're gonna have a Counter-Strike stream at 3K. We're gonna do a Premiere. We're gonna do Premiere games. I'm a 15,000 rank right now on Premiere. We're gonna try to grind to 16 or 16.5. I haven't played in like a week and a half though, so I need to get the aim back up. And then we're gonna do some cases and give away skins. Okay. Yeah. That's a good idea, or who said that? Tabor. Yeah, Tabor. We're going to nest the pricing information further. This was just to kind of get started, and then we're going to kind of mimic Depop's pricing structure, I think, because I did like it. But this is just for now, just to get all the information we need, some boilerplate, and then we can further reconfigure or refactor from there. But cool, this was successful. Let's go ahead and move on to MIT. So what we did right here was we linked up the ability with our new file structure, right? We created some new files. We created new structure to our project here, made it really nice and neat, which is really cool. And then we fixed all of our paths back together, and then we successfully are now updating the match products from the database to the products that were found in the Depop parse, and then updating the products in the database, with the relevant Depop information for said product, and then it all saves accordingly, which is really nice. And we get the pictures sorted out and organized to parse from the page. We're not really parsing the page, we're intercepting the network response and then just extracting out from the JSON there. So it's really not much of a parse anymore. We started off by parsing, and we've refactored quite a few times from just raw parsing as we scroll, and then opening up each page individually one by one, and then asynchronously, and now just doing this with kind of our item number in the description kind of hack, or rather just kind of more optimized solution. Just a little bit of work up front can save us a lot of time in the end, so it's probably the best way to go. just by having to manually put the item number in the description of the Depop listing so we can parse it out and link it to the database with our script. So sweet, let's go ahead and push that up. Get add. We'll say fixed file pathing.
Do I now need to learn coding? Yes, yes I do.
And that's fine. All right, let's go ahead and move on to some MIT. How about, yeah? So if you guys aren't familiar, we have been taking this MIT Introduction to Computational Thinking and Data Science course. It's a great course offered by these instructors. We haven't gotten a lecture from Anna yet, but I'm sure we will. So far, we have been going through and we're on lecture 8, sampling and standard error. We're getting into more kind of statistical based programming, off of our modeling and random walks and Monte Carlo simulations to eventually get into kind of machine learning and things along those lines, which is also a path I'm trying to go down here. So, which is going to be fun. So we're going to continue on with this. And then if we have some energy after the lecture, I might watch or might do some reading out of our Introduction to Algorithms book that we started yesterday and get into chapter 2 and then kind of call it a night from there. But let's go ahead and get into lecture 8 here. Sampling and standard error. I am going to be posting. I recorded our read aloud, so I read the entire chapter word for word aloud on stream of the Introductions to Algorithms book, which is kind of like the Bible for beginner programmers learning algorithms, in their undergraduate. I think our boy Tim in here says he's even using it in his graduate program. So I highly suggest you guys. I'm going to be chopping that recording up to kind of like an audio book, but also have a visual component, so you guys can listen to it back and just throw it in and listen to it as you read for an audio book, to have that too. Because I didn't find that I tried to have AI read it to me and it was too robotic, and then all the like the Speechify services, they all were pay to play, and so we're not doing that. We're here to learn, and we learn for free. So appreciate you guys being here and joining me. Let's go ahead and pause the tunes here. Oh boy, we're gonna get hit with
What do
a.
you think about VBA coding like using cursor?
I use so people ask me this quite a bit, so I'll address it right here, right now. In regards to AI and stuff, I do use AI. I have ChatGPT over on the side window here. I do use it to talk about like next steps in my project.
Great.
As you can see, it's a lot of just words going over things, talking about like what I would like, learning, reading about what options I have, option 1, 2, and 3 of different questions I have. So, a lot of my prompts are not just my a copy of my code and just paste it in and saying, hey, fix this. It's usually like 90, I'd say 5 to 9% of the time. That's not the case. It's usually if I do copy it in, I say I am having trouble with this code or wanting to understand more. Can we go line by line and explain what's happening, and then I will preface, don't show me code a lot of the times, or don't write code. Let's talk verbally. You will see me come on here and use the text to speech feature, right? I'll show you an example. I'm wanting to talk about my project and potentially some use cases for using React versus vanilla HTML. I've used React in the past and I found it, useful, but is it kind of overkill for this kind of project, blah, blah, blah. And so sometimes you'll see me talk and give like a minute long prompt or 2 minute long prompt, and it's a real paragraph, and I really have a conversation with it as I was having with like a peer or a TA or something, and your TA would never just give you code and let you cheat. So I keep that same philosophy as well. Now, there are some sunken costs into the learning where I feel the AI can really the AI can really give you an advantage to remove those sunk costs to where you like so the sunk cost fallacy is where you have so much time and energy invested into a certain topic that you might be struggling with that you continue to struggle with, and there might be some light at the end of the tunnel if you're able to conquer that and actually come out of it. But if you continue to spiral and learn the wrong thing, a lot of the times it can be damaging. And so what the AI I've learned is helpful in is that when you find yourself kind of going down those spirals of really just not getting it, kind of doing more harm than good, is that it can really reel you back in and provide you just a little bit that just maybe learn from an answer rather at that point in time. So, you know, there is some, justifications to getting some answers sometimes, I think, as long as you're learning from them and have done the actual due diligence ahead of time on your own. But that's just my ramble. Anyways, let's go ahead and let the Discord know we're watching MIT. Starting lecture 8 of MIT 6.0002. Okay. Let's go into here. Let's grab out our notes. So I take notes and I have tons of repos for all of my notes in the courses: CS50P, CS50X, um, MIT OpenCourseWare. We have one so far for calculus, one that we still haven't really done much in. A revisit to calculus. You guys can find my notes live on my GitHub and follow along there. I do my best to kind of keep a good Spark notes for everybody and myself to go back and reference as well. So let's go lecture 8 notes.md. And then we're going to do here. Let's just see, I just did this title. I need to take some better notes for lecture 7, that's for sure. Definitely fell through the cracks on that guy. Lecture 7 was a lot more like kind of code. It was a lot of code, I think, right? If I remember right. So lecture 8 is sampling and standard error. Okay. So after lecture 8, we do have problem set 3 that we have to complete before we move on. So we will be doing that one in the upcoming days here. All right. Let's get caught up on chats and let's get started here. Pursue a master's in biochem? No way. If I was going to do a master's in anything, it'd be computer science for sure. But I'm not sure if the master's is the way to go anymore. If it's kind of like out of the meta. What do you guys think? All right, let's get started here. Let me get the recording going for the watch along here. Okay, let's make the volume right. All right, hello everybody. My name is Michael, and welcome back to the channel. Hope you're having a wonderful day so far. Today we're going to be jumping back into MIT OpenCourseWare, more specifically the MIT 6.0002 Introduction to Computational Thinking and Data Science course from fall 2016. This is going to be lecture 8, Sampling and Standard Error. I stream every single day around 7 p.m. PST as I teach myself computer science and programming. And if you would like to join me, you can do so as I watch lectures like this, build projects, and the like. So thank you guys so much for being here, and let's get started. All right, banged out that intro. Let's roll.
Is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or to view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
All right, let's roll.
Welcome to Lecture 8. So we're now more than halfway through the
More than halfway, boys. Let's go. Come
All
on.
right. The topic
Woo!
of today is sampling. I want to start by reminding you about this whole business of inferential statistics. We make references about populations by examining one or more random samples drawn from that population. We used Monte Carlo simulation over the last 2 lectures. And the key idea there, as we saw in trying to find the value of pi, was that we can generate lots of random samples and then use them to compute confidence intervals. And then we use the empirical rule to say, all right, we really have good reason to believe that 95% of the time we run this simulation, our answer will be between here and here. Well, that's all well and good when we're doing simulations. But what happens when you have to actually sample something real? For example, you run an experiment and you get some data points, and it's too hard to do it over and over again. Think about political polls. Here's was an interesting poll. How are these created? Not by simulation. They didn't run 1,000 polls and then compute the confidence interval. They ran one poll of 835 people in this case. And yet, they claim to have a confidence interval. That's what that margin of error is.
According to the most recent poll, Clinton leads Trump by 3.2%. In swing states, registered voters.
They needed that large confidence
margin
interval.
Of error plus or minus 4%.
So how is this done?
Percentage points.
Well, it's backing up for a minute. Let's talk about how sampling is done when you are not running a simulation. You want to do what's called probability sampling, in which each member of the population has a non-zero probability of being included in a sample. There are, roughly speaking, 2 kinds. We'll spend really all of our time on something called simple random sampling. And the key idea here is that each member of the population has an equal probability of being chosen in the sample. All right, so there's no bias. Now, that's not always appropriate. And I do want to take a minute to talk about why. So suppose we wanted to survey MIT students to find out what fraction of them are nerds, which, by the way, I consider a compliment.
100%.
So suppose we wanted to consider a random sample of 100 students. We could walk around campus and choose 100 people at random. And if 12% of them were nerds, we would say 12% of the MIT undergraduates are nerds, if 98%, et cetera. Well, the problem with that is let's look at the majors by school. This is actually under the majors at MIT by school, and you can see that they're not exactly evenly distributed. And so if you went around and just sampled 100 students at random, there'd be a reasonably high probability that they would all be from engineering and science. And that might give you a misleading notion of the fraction of MIT students that were nerds. Or it might not. In such situations, we do something called stratified sampling, where we partition the population into subgroups and then take a simple random sample from each subgroup. And we do that proportional to the size of the subgroups. So we would certainly want to take more students from engineering than from architecture, but we probably want to make sure we got somebody from architecture in our sample.
Architecture. Okay, I was wondering what that meant.
This, by the way, is the way most political polls are done. They're stratified. They say we want to get so many rural people, so many city people, so many minorities, things like that. And in fact, that's probably where the recent polls were all messed up, is they did a very, retrospectively at least, a bad job of stratifying. So we use stratified sampling when there are small groups, subgroups that we want to make sure are represented, and we want to represent them proportional to their size in the population. This can also be used to reduce the needed size of the sample.
Okay.
If we wanted to make sure we got some architecture students in our sample, we'd need to get more than 100 people to start with. But if we stratify, we can take fewer samples. It works well when you do it properly, but it can be tricky to do it properly. And we are going to stick to simple random samples here. All right, let's look at an example. So this is a map of temperatures in the United States. And so our running example today will be sampling to get information about the average temperatures. And of course, as you can see, they're highly variable, and we live in one of the cooler areas. The data we'll be going to use is real data, and it's in the zip file that I put up for the class from the US Centers for Environmental Information. And it's got the daily high and low temperatures for 21 different American cities every day from 1961 through 2015.
Okay.
So it's an interesting data set. A total of about
Environmental studies,
422,000
daily high and low temperatures
examples
for
in the
21
data set.
different cities.
So a
between
fairly
this time
good-sized
frame
data set.
And then this many
It's
data
fun to
points.
play
Let's
with.
look at some code of the data. Great. Okay.
All right, so we're sort of in the part of the course where the next series of lectures, including today, is going to be about data science, how to analyze data. I always like to start by actually looking at the data, not looking at all 421,000 samples, but giving a plot to sort of give me a sense of what the data looks like.
Okay.
I'm not going to walk you through the code that does this plot. I do want to point out that there are two things in it
that
we may not have seen before.
Standard deviation, easy.
So
A sample gives a
simply
population
enough,
and
I'm
a
gonna
size,
use
returns a list containing a sample
numpy.std
size
to
for
get
randomly
standard
chosen
deviations
distinct elements of the
instead of
population.
my own code for
Sampling
it.
without replacement.
And random.sample to take simple random samples from the population.
Cool.
Random.sample takes two arguments. The first is some sort of a sequence of values, and the second is an integer telling you how many samples you want, and it returns a list containing sample size randomly chosen distinct elements. Distinct elements is important because there are two ways that people do sampling. You can do sampling without replacement, which is what's done here, that you take a sample
You don't put
and
it
then it's
back.
out of the population so you won't draw it the next time.
Yep.
Or you can do sampling with replacement, which
Or you
allows
put
you
it
to
back.
draw the same sample multiple times, the same example multiple times. We'll see later in the term that there are good reasons that we sometimes prefer sampling with replacement. But usually we're doing sampling without replacement, and that's what we'll do here.
All right.
So we won't get Boston on April 3rd multiple times, or not the same year at least.
All right, sounds good.
All right, so here's the histogram the code produces. You can run it yourself now if you want, or you can run it later. And here's what it looks like. The daily high temperatures, the mean is 16.3 degrees Celsius. I sort of vaguely know what that feels like.
So quite a number of days.
And as
about
you can see, it's
20,
kind of an
25
interesting
C.
distribution. It's not normal,
18,
but
20
it's
C.
not that far, right? We have a little tail of these cold temperatures on the left, and it is
You
what
did
it
have
is.
some
It's
crazy
not a normal
hot days. It
distribution,
did
and
kind
we'll
of
later
skew
see that
this,
doesn't
but
really
a
matter.
little bit more normal here with a,
Okay, so this gives me a sense.
but it kind of averages.
The
to a
next thing,
normal.
I'll get us some statistics. So we know the mean is 16.3, and the standard deviation is approximately 9.4 degrees.
Okay.
So, And if you look at it, you can believe that. Well, here's a histogram of one random sample of size 100.
So they just took one random
looks pretty
sample
different,
of size
as you might
100
expect.
from this data set, right?
Its standard deviation is 10.4. Its mean 17.07.
Not too far away.
So
1707.
even though the figures
not
look a little
too far
different,
away.
in fact, the means and standard deviations are pretty similar.
Yeah, not too bad.
If we look at the population mean and the sample mean, and I'll try and be careful to use those terms, they're not the same, but they're in the same ballpark. And the same is true of the two standard deviations.
Yeah.
Well,
should we?
that
is this
raises
accident,
the question,
or should we
did we
expect
get lucky?
something else?
Or
Let's try
is it
1,000
something
times.
we should expect? If we draw 100 random examples, should we expect them to correspond to the population as a whole? And the answer is sometimes yeah, and sometimes no. And that's one of the issues I want to explore today. So one way to see whether it's a happy accident is to try it 1,000 times. We can draw 1,000 samples of size 100 and plot the results. Again, I'm not going to go over the code. There's something in that code as well that we haven't seen before.
line
And that's the ax.vline
draws a
plotting
red
command.
vertical line at
V for
pop
vertical.
mean on the x-axis.
It just, in this case, will draw a red line.
So
as I said, the color
x-axis
is
vertical
R,
line.
at population mean on the x-axis.
So it just draws a vertical line at that part.
So
at
that'll
this
just
x
show us where the
equals.
mean is. If we
Okay.
wanted to draw a horizontal line, we'd use ax h line. Just showing you a couple of useful functions.
So axis vertical line,
When we
axis
try it
horizontal.
1,000 times, here's what it looks like.
And that's that
So-
red line there.
Here we see what we had originally. Same picture I showed you before. And here's what we get
Of the
when
means
we
of
look
the
at
samples.
the means of 100 samples. So
Much more.
this plot on the left
normal.
looks a lot more like it's a normal distribution than the one on the right.
We're right there with
Did
you,
that
John.
surprise us?
Right there with you, my guy. No, we see
Or
them
is
in
there a
nature,
reason
right?
we should have expected that to happen? Well, what's the answer? Someone tell me why we should have expected it. It's because of the central limit theorem, right?
The
That's
central
exactly
limit
what the central limit theorem promised us would happen.
there. Yeah.
And sure enough, it's pretty close to normal. So that's a good thing. And now if we look at it, we can see that the mean of the sample means is 16.3. And the standard deviation of the sample means is 0.94. So if we go back to what we saw here, we see that actually, when we run it 1,000 times and look at the means,
Much more
we
closely
get
related.
very close to what we had initially.
Yeah.
So indeed, it's not a happy accident. It's something we can in general expect.
So we have this inference that the samples
What's the
reflect the
95%
population.
confidence interval here? Well, it's going to be 16.28 plus or minus 1.96 times 0.94, the standard deviation of the sample means. And so it tells us that the confidence interval is the mean high temperature is somewhere between 14.5 and 18.1. Well, that's actually a pretty big range, right? It's sort of enough to you to where you wear
That's
a
the
sweater, you don't wear
95%
a sweater.
confidence interval factor, right? This is the standard deviation, and this
So
is
the
by
good
the
news
original.
is it includes the population mean. That's nice. But the bad news is it's
Or is this just
pretty
rounded?
wide.
This might be just rounded.
Suppose we wanted a tighter bound. I said, all right, sure enough, the
A
central
4 unit
limit
wide
theorem is going to tell
bound?
me the mean of the
3.4.
means is going to give me a good estimate of the actual population mean.
Barely goes
But
up.
I want a tighter bound. What can I do? Well, let's think about a couple of things we could try. Well, one thing we could think about is drawing more samples.
Okay, so the
Suppose
larger the
instead of
sample size,
1,000 samples, I'd taken 2,000
the
or
higher the
3,000
standard
samples.
deviation.
We can ask the question, would that have given me a smaller standard deviation?
Potentially, right?
For those of you who have not looked ahead, what do you think? Who thinks it will give you a smaller standard deviation?
You don't raise your hand.
Who
Don't
thinks
raise
it
your hand.
won't? And the rest of you have either looked ahead or refused to think. I'll prefer to believe you looked ahead. Well,
So the deviation
we can run the
between each
experiment,
sample
go to the
doesn't
code, and
change
you'll
because
see
you
that
still have 100
there's a
samples being
constant of
compared to
1,000,
one
which you can
another,
easily change
right?
to 2,000,
And
and
then
lo
you're
and
just
behold, the
drawing
standard
100
deviation
samples,
barely budges.
2x
Got a
more
little
times.
bit bigger as it happens.
But instead, if
that's
you
kind of an
increase the
accident.
sample size, the simple
It
random
just
sampling
more or less
size,
doesn't
right, of the
change.
population,
And it won't change
your
if I go to
deviation
3,000
now
or
has
4,000 or
like
5,000.
a double
It'll
chance,
wiggle
basically,
around,
not
but it won't help
proportionally
much.
or linearly, but like you have double the amount
So
of sample
what we can
size,
see is doing it more often
which thus
is not gonna help.
dramatically decreases the standard deviation
Suppose we take
because you
larger
have more
samples.
potential deviation between
that gonna
each
help?
data point
Who thinks that will
in
help?
theory.
And who thinks it won't? Okay, well, we can again run the experiment. I did run the experiment. I changed the sample size from 100 to 200.
I wish I was there so I could ask questions.
And again, you can
I'd
run
raise
this
my
if you
hand.
want.
I wouldn't care.
And if you run it, you'll get a result, maybe not exactly this, but something very
They
similar.
probably think I was dumb.
That indeed,
Get this guy out
if
of
I
here.
increased the size of the
guy
sample
even
rather
in
than
this
the number of
class?
the samples, the standard deviation drops fairly dramatically. In this case, from 0.94 to 0.66. So that's a good thing. I now want to digress a little bit before we come back to this and look at how you can visualize this, because this is a technique you'll want to use as you write papers and things like that, is how do we visualize the variability of the data? And it's usually done with something called an error bar. You've all seen these things here. And this is one I took from the literature. This is plotting pulse rate against how much exercise you do, or how frequently you exercise. And what you can see here is there's definitely a downward trend, suggesting that the more you exercise, the lower your average resting pulse. That's probably worth knowing. And these error bars give us the 95% confidence intervals for different subpopulations. And what we can see here is that some of them overlap. So yes, once a fortnight, 2 weeks for those of you who don't speak British, it does get a little
Gamers
bit
in here just heard
smaller than
Fortnite and immediately
rarely
just
or
woke
never,
up, started paying
but
attention.
the
Come on,
confidence
guys.
interval is very big.
Wake up,
And
wake
so
up.
maybe we really shouldn't feel very comfortable that it would actually help. The thing we can say is that if the confidence intervals don't overlap, we can conclude that the means are actually statistically significantly different, in this case at the 95% level. So here we see that the more than weekly does not overlap with the rarely or never. And from that, we can conclude that this is actually statistically true, that if you exercise more than weekly, your pulse is likely to be lower than if you don't. If confidence intervals do overlap, you cannot conclude that there is no statistically significant difference. There might be, and you can use other tests to.
Okay, so if confidence intervals overlap, you can not conclude A statistical what?
Confidence intervals do overlap. You cannot conclude that there is no statistically significant difference. There might be, and you can use other tests to find out whether there are. When they don't overlap, it's a good thing. You can not conclude that there is no statistically significant difference. There might be, and you can use other tests to find out whether there are. When they don't overlap, it's a good thing. We can conclude something strong. When they do overlap, we need to investigate further. All right, let's look at the error bars for our temperatures. And again, we can plot those using something called pylab.errorbar. So what it takes is two values, the usual x-axis and y-axis. And then it takes another list of the same length, or sequence of the same length, which is the y errors. And here I'm just going to say 1.96 times the standard deviations. Where these variables come from, you can tell by looking at the code.
So that's just the confidence interval
and then
range, right?
I can say the format, I want an O
The absolute value.
to show the mean, and then a label. FMT stands for format. Error bar has different keyword arguments than plot. You'll find as you look at different ways, like histograms and bar plots, scatter plots, they all have different available keyword arguments, so you have to look up each individually. But other than this, everything in the code should look very familiar to you.
Okay.
And when I run the code, I get this. And so what I've plotted here is the mean against the sample size with error bars.
Mean against the sample size with error bars.
And 100 trials in this case.
And a horizontal line.
So what you can see is that as the sample size gets bigger, the error bars get smaller. The estimates of the mean don't necessarily get any better. In fact, we can look here, and this is actually a worse estimate relative to the true mean than the previous two estimates.
Interesting, right?
But we can have more confidence in it. The same thing we saw on Monday when we looked at estimating pi. Dropping more needles didn't necessarily give us a more accurate estimate, but it gave us more confidence in our estimate.
Yeah.
And the same thing is happening here. And we can see that steadily we can get more and more confidence. So, larger samples seem to be better. That's a good thing. Going from a sample size of 50 to a sample size of 600, reduce the confidence interval, as you can see, from
0.34.
a fairly large, the confidence interval here ran from just below 14 to almost 19, as opposed to 15 and a half or so to 17. I said confidence interval here. I should not have. I should have said standard deviations. That's an error on the slides. Okay, what's the catch? Well, we're now looking at 100 samples, each of size 600.
600.
So we've looked at a total of
600,000 samples.
600,000 examples. What has this bought us? Absolutely nothing.
Is that right?
Right. The entire population only contained about 422,000 samples. We might as well have looked at the whole thing.
It's not
rather
60,000?
than take a few of them. So it's like, you might as well hold an election rather than ask 800 people 1,000 times who they're going to vote.
Is that not
times
a
who they're gonna
typo?
vote
Is that
for.
supposed to be 60,000?
All right, so sure it's good, but it gave us nothing.
This thing is full of typos.
Suppose we did it only once. Suppose we took only one sample, as we see in political polls. What can we conclude from that? And the answer is actually kind of surprising, how much we can conclude in a real mathematical sense from one sample. And again, this is thanks to our old friend, the central limit theorem. So if you recall the theorem, it had 3 parts. Up till now, we've exploited the first 2. We've used the fact that the means will be normally distributed so that we could use the empirical rule to get confidence intervals, and the fact that the mean of the sample means would be close to the mean of the population. Now I want to use the third piece of it, which is that the variance of the sample means will be close to the variance of the population divided by the sample size. And we're going to use that to compute something called the standard error of the, formerly the standard error of the mean. People often just call it the standard error. And I will be, alas, inconsistent. I sometimes call it one, sometimes the other. All right. It's an incredibly simple formula. It says the standard error is going to be equal to sigma, where sigma is the population standard deviation, divided by the square root of n, which is going to be the size of the sample.
So standard error.
And then there's just this very small function that implements it. So we can compute this thing called the standard error of the mean in a very straightforward way. Well, we can compute it, but does it work? What do I mean by work? I mean, what's the relationship of the standard error to the standard deviation? Because remember, that was our goal, was to
Variance of the sample means
understand
will be close to the variance
the standard deviation so we could
of the
use the
population
empirical.
divided by the sample size.
Well, let's test the standard error of the mean. So here's a slightly longer piece of code. I'm going to look at a bunch of different sample sizes from 25 to 600, 50 trials each. So get highs is just a function that returns the temperatures. I'm going to get the standard deviation of the whole population. Then the standard error of the means and the sample standard deviations both. And then I'm just going to go through and run it. So for size and sample size, I'm going to append the standard error of the mean.
Is expected to vary from the true population
And remember,
mean.
that uses the population standard deviation and the size of the sample. So I'll compute all the SEMs. And then I'm going to compute all the actual standard deviations as well. And then we'll produce a bunch of plots, or a plot, actually.
A measure of how much the
All
sample
right.
mean
So let's see what that
is
plot
expected
looks
to
like.
vary from the true population mean.
Pretty striking. So we see the blue solid line is the standard deviation
Of 15
Of-
means.
the 50 means, and the red dotted line is the standard error of the mean.
So pretty similar.
So we can see quite strikingly here that they really track each other very well. And this is saying that I can anticipate what the standard deviation would be by computing the standard error, which is really useful, because now I have one sample, I compute its standard error, and I get something very similar to what I get of the standard deviation if I took 50 samples and looked at the standard deviation of those 50 samples. All right, so not obvious that this would be true, right? That I could use this simple formula and the two things would track each other so well. And it's not a coincidence, by the way, that as I get out here near the end, they're really lying on top of each other. As the sample size gets much larger, they really will coincide. Okay, so 1, does everyone understand the difference between the standard deviation and the standard error? No, okay. So how do we compute a standard deviation? To do that, we have to look at many samples, in this case 50, and we compute how much variation there is in those 50 samples. For the standard error, we look at 1 sample, and we compute this thing called the standard error, and we argue that we get the same number, more or less, that we would have gotten had we taken 50 samples or 100 samples and computed the standard deviation. So I can avoid taking all 50 samples if my only reason for doing it was to get the standard deviation. I can take 1 sample instead and use the standard error of the mean. So going back to my temperature, instead of having to look at
so it's just a reference
lots
of
of
one
samples, I only have to
parameter
look at 1.
against the
And I
population,
can
whereas
get
the
a
standard
confidence interval.
deviation
That makes
is
sense? Okay. There's a catch.
many.
Notice that the formula for the standard error includes the standard deviation of the population, not the standard deviation of the sample.
Yeah.
Well, that's kind of a bummer, because how can I get the standard deviation of the population without looking at the whole population? And if I'm going to look at the whole population, then what's the point of sampling in the first place? So we have a catch, that we've got something that's a really good approximation, but it uses a value we don't know. So what should we do about that? Well, what would be really the only obvious thing to try? What's our best guess at the standard deviation of the population if we have only 1 sample to look at?
1.
Now, what would you use? Somebody? I know I forgot to bring the candy today, so no one wants to answer any questions.
The 95.
The standard deviation of samples, all I got. So let's ask the question, how good is that? Shockingly good.
Oh, so you just using.
So I looked at our example here for the temperatures, and I'm plotting the sample standard deviation versus the population standard deviation for different sample sizes, ranging from 0 to 600 by 1, I think. So what you can see here is when the sample size is small, I'm pretty far off. I'm off by 14% here. And I think that's 25. But when the sample size is larger, say 600, I'm off by about 2%. So what we see, at least for this data set of temperatures, if the sample size is large enough, the sample standard deviation is a pretty good approximation of the population standard deviation. Well, now we should ask the question, what good is this? Well, as I said, once the sample reaches a reasonable size, and we see here reasonable is probably somewhere
Sample to standard
around
is pretty good
500.
approximation.
It becomes a good approximation. But
Right.
is it true only for this example? The fact that it happened to work for high temperatures in the US doesn't mean that it will always be true. So there are at least 2 things we should consider to asking the question, when will this be true, when won't it be true?
Okay.
One is, does the distribution of the population matters? So here we saw in our very first plot the distribution of the high temperatures, and it was kind of symmetric around a point, not perfectly, but not everything looks that way, right?
Yeah.
So we should say, well, suppose we had a different distribution.
Just random numbers.
Would that change this conclusion?
Okay, so we have 3 lists: uniform,
And the other
normal,
thing
and
we should
exponential.
ask is, well, suppose we had a different size population. Suppose instead of 400,000 temperatures, I had 20 million temperatures. Would I need more than 600 samples for the two things to be about the same? Well, let's explore both of those questions. First, let's look at the distributions, and we'll look at 3 common distributions: a uniform distribution, a normal distribution, and an exponential distribution.
Okay.
And we'll look at each of them for
So 100,000 data points.
100,000.
We're going to do a random
points.
random.
So we know we can generate a uniform distribution by calling
Gaussian,
random.random.
Expo variant.
Gives me a uniform distribution of real numbers between 0 and 1. We know that we can generate a normal distribution by calling random.Gauss. In this case, I'm looking at it with a mean of 0 and a standard deviation of 1. But as we saw in the last lecture, the shape will be the same independent of these values. And finally, an exponential distribution, which we get by calling random.expovariate. And this number, 0.5, is something called lambda, which has to do with how quickly the exponential either decays or goes up, depending upon which direction. And I'm not going to give you the formula for it at the moment, but we'll look at the pictures, and we'll plot each of these discrete approximations to these distributions.
Okay.
So here's what they look like. Quite different, right? We've looked at uniform and we've looked at Gaussian before, and here we see an exponential, which basically decays and will asymptote towards 0, never quite getting there.
Yeah.
But as you can see, it is certainly not very symmetric around the mean. All right, so let's see what happens. If we run the experiment on these 3 distributions, each of 100,000 point examples, and look at different sample sizes, we actually see that the difference between the standard deviation and the sample standard deviation, or the population standard deviation, is not the same. Right? We see down here, this looks kind of like what we saw before, but the exponential one is really quite different.
Yeah.
You know, its worst case is up here at 25. The normal is about 14, so that's not too surprising since our temperatures were kind of normally distributed when we looked at it. And the uniform is initially much better approximation. And the reason for this has to do with the fundamental difference in these distributions of something called skew. Skew is a measure of the asymmetry of a probability distribution. And what we can see here is that skew actually matters. The more skew you have, the more samples you're going to need to get a good approximation. So if the population is very skewed, very asymmetric in the distribution, you need a lot of samples to figure out what's going on. If it's very uniform, as in, for example, the uniform population, you need many fewer samples.
Butchered the spelling on that one.
Okay, so that's an important thing. When we go about deciding how many samples we need to have some estimate of the skew in our population. All right, how about size? Does size matter? Shockingly, at least it was to me the first time I looked at this, the answer is no. That if we look at this, and I'm looking at it just for the uniform distribution, but we'll see the same thing for all 3. it more or less doesn't matter. Quite amazing, right? If you have a bigger population, you don't need more samples. And it's really almost counterintuitive to think that you don't need any more samples to find out what's going to happen if you have 1,000,000 people or 100 million people. And that's why when we look at, say, political polls, they're amazingly small, right? They poll 1,000 people and claim they're representative of Massachusetts.
Huh. Interesting. That's
All
really
right.
interesting, actually.
This is good news. So to estimate the mean of a population given a single sample, we choose a sample size based upon some estimate of skew in the population. This is important because if we get that wrong, we might choose a sample size that's too small. And in some sense, you always want to choose the smallest sample size you can that will give you an accurate answer, because it's more economical to have small samples than big samples.
Based on the estimate of skew. Okay.
And I've been talking about polls, but the same is true in an experiment. Now, how many pieces of data do you need to collect when you run an experiment in a lab? And how much will depend, again, on the skew of the data, and that will help you decide. Once you know the size, you choose a random sample from the population.
You mean a standard deviation of the sample.
Then you compute the mean and the standard deviation of that sample. And then use the standard deviation of that sample to estimate the standard error. And I want to emphasize that what you're getting here is an estimate of the standard error, not the standard error itself, which would require you to know the population standard deviation. But if you've chosen the sample size to be appropriate, this will turn out to be a good estimate. And then once we've done that, we use the estimated standard error to generate confidence intervals around the sample mean, and we're done. Now, this works great when we choose independent random samples.
Okay.
And as we've seen before, that if you don't choose independent samples, it doesn't work so well. And again, this is an issue, right, where if you assume that in an election, each state is independent of every other state, and you'll get the wrong answer because they're not. All right, let's go back to our temperature example and pose a simple question. Are 200 samples enough?
Okay.
I don't know why I chose 200, I did. So we'll do an experiment here. This is similar to an experiment we saw on
T in the
Monday.
range of number of trials, or in loop
So
over
I'm
the number
starting
of
with
trials.
the number of mistakes I make.
Sample is
For
equals to a
T in
random
range number
sample,
of trials,
given
sample
the
will be
temps
random
list
dot
and
sample
sample size.
of the temperatures in the sample size.
Sample mean is the sum of the sample
This is a key step.
list, right? Divided by the sample
The
size.
first time I did this, I
the
messed
standard
it
error
up.
is
And
the standard
instead
deviation
doing
of the
this very
sample
simple
divided
thing, I did
by
a more
square root of the
complicated
sample
thing
size.
of just choosing some point in my list
So
of
if the
temperatures
absolute
and
value
taking
of
the
the
next,
population mean
the next 200
less than the
temperatures,
sample mean
why did that give
is
me the
greater
wrong answer?
than the confidence interval of the 95%,
Because it's
then
organized
that
by
is a
city.
bad number.
So if I happen to choose the first day of Phoenix,
So we're going to print how
all
many
200
numbers
temperatures were
basically are
Phoenix,
bad until we get
which is
a
not a very
value
good
to where we
approximation of the
have
temperature
a sample
in the country as
size
a whole.
that will
But
give
this
us
will work.
an
I'm using
appropriate,
random.sample. I'll then get the sample mean.
confidence of
and then I'll
95%
compute my
relative
estimate
to
of
the
standard
population,
error, but by taking that as seed here.
right?
And then if the absolute value of the population minus the sample mean is more than 1.96 standard errors, I'm going to say I messed up, right? It's outside. And then at the end, I'm going to look at the fraction outside the 95% confidence intervals, and what do I hope it should print? What would I What would be the perfect answer when I run this? What fraction should lie outside that?
5%.
Well, it's a pretty simple calculation.
Let's go. I'll be getting these MIT reps. Let's go. Get me in
Because
this
if they
class.
all
Come on,
were
MIT. Hit
inside,
me
then
up. Get
I'm
me in the
being too
class. Let me
conservative
liven
in
up
my
this
interval, right?
class. Let me get some
I want 5%
juice
of
going.
the
Let me get
tests
some-
to fall outside
let me wake this
the
thing up.
95% confidence interval.
Me and John would be having a
Right? If I wanted
like a
fewer, then I would
Q&A
look
session.
at
We'd be having a
3 standard
conversation if I was
deviations
there.
instead of 1.96. Then I would expect less than 1% to fall outside.
I'd be like those guys that's like,
So this is something we have
man,
to always
if
keep
there's
in
girls
mind
here,
when
I'd
we do this
totally
kind
be
of thing.
off the
If
wall.
your
and
answer is too
spitting
good,
game.
you've messed up. Right?
Next thing you know,
It shouldn't be too bad, but it
stuck
shouldn't
on the
be
wall.
too good either. Right? That's what probabilities are all about. If you called every election correctly, then your math is wrong. All right, well, when we run this,
oh, let's go.
we get this lovely answer, that the fraction outside the 95%
About
confidence
5%.
interval is 0.0511. That's exactly, well, close to what you want. It's almost exactly 5%.
Trials, the number of trials.
And
is 5%
if I
of
run
the
it
trials that
multiple
died.
times, I get slightly different numbers, but they're all in that range, showing that here, in fact, it really does work. Okay, so that's what I want to say, and it's really important, this
That's what I
notion
want
of
to
the
say, and I'm
standard
going to say
error.
it.
When I talk to other departments about what we should cover in 60002, about the only thing everybody agreed on was we should talk about standard error. So now I hope I've made everyone happy, and we will talk about fitting curves to experimental data starting next week. All right, thanks a lot.
Lecture, we'll say lecture 8 slides. Cool. Awesome. Awesome, possum, rossum, Mick, awesome. All right, sweet. So that was a, honestly, I learned a lot of that stuff back in my, my undergraduate, in my, like, statistics courses. My statistics 3000, statistics for scientists was a big course that I took my junior year. I did take it over COVID though, so a lot of it did kind of fade quickly as it was all like online learning and whatnot. So it's all it's good to get some refresher on like these confidence intervals, the central limit theorem, standard error, skew, all these kind of stuff for graph, models and distributions and whatnot. It's really good information. So that was the MIT 6.0002 course for Lecture 8 on sampling and standard error. We will continue on in the next one. All right, you guys. Thank you. Cool. I just stopped the recording there. All right. Let's catch up on some chats here. That was Lecture 8, you guys. Nice. I'll chop up that recording and put it to the channel so you guys can watch back and watch the lecture in a condensed format and get the kind of meat and potatoes of it. Yeah, that's the goal, Insomniac. We're going to try to use this class to kind of transition into machine learning. I'm really trying to actually gain like a really solid understanding in this, not just kind of throw together, some, half-baked projects and really not understand what I'm doing. I want to be able to write the models and code that I'm using and understand what's going on and be able to actually contribute. So as we get into the back half of the 6.0002 course of MIT OpenCourseWare, Introduction to Computational Thinking and Data Science, it starts to branch into machine learning. So this is a great introduction, as Insomniac is saying. So we're super excited to get into that, and we got to keep chugging along. We're over halfway done with the course. We're gonna do problem set number 3 next. That one is pretty long, so I might have to grind that one over the course of a couple streams maybe, but Yeah, that was awesome. What did you guys think of that one? No idea, Juan. No idea. I ain't no hacker. Hey, how's it going, Diego? Thanks for coming in, my guy on Twitch. I appreciate you. Feel free to follow along if you are. Appreciate you so much for coming in. You're awesome, my guy. Cool, you guys. All right, leave a like on stream on YouTube if you're here. You guys can get access to these notes on my GitHub. They are on my GitHub, so git add, git commit. We'll say finish. Complete lecture 8. Push. So if you guys would like to see my notes and have a kind of a follow along here with the course, I also have my problem sets in here as well. And so we're going to do problem set 3 next time. Problem set 3 is 14 pages long on this PDF. Oh my god. So this one is going to be a doozy. Oh my gosh. This one's going to be a little challenging. Hopefully it's not too bad. There's quite a few problems here. Hopefully we don't have to do them all. Maybe we get to pick and choose, but yeah, that one's going to be tough. I'm not looking forward to that, but we'll get it done, boys. We'll get it done. All right, you guys. Cool. Okay, it's 8:40. All right, you guys. So earlier in the stream, we worked on our project here. We went over the parser and fixed a little bit of bugs we were having with our data being overrode when we did the linkage between our database and the scraping of the item. Now we fixed that. Then we went ahead and watched the next portion of the MIT 6.0002 course from MIT OpenCourseWare, which is awesome, and which was really, really good stuff by Mr. John.
Is that people do
MCTS. What is that, Insomniac? All right, you guys. I think I'm going to head out for tonight. I'll be back tomorrow. We'll continue on. Thank you guys so much for being here, and have yourselves a really good night. Thank you guys so much. Bye, guys.